Hello, welcome to Maps of Math. Today I'm going to do a video on what are epis and monos, or epimorphisms and monomorphisms. So as to what these are um, two different dual types of informative probes. So you're in some category, these are going to tell us certain bits of information about about morphisms, and they're dual so that one's on one side, one's on the other. Um, epis, or epimorphisms, they're going to preserve determinacy on the target. So their focus is going to be on the target side. Monos or monomorphisms, they're going to preserve distinguishability on the source. Pardon me. All right, so setup. We got some morphism F. We're in a category C. F is between X and Y. And so as is typical, we're going to focus on one of the two sides. So we'll focus on one, then the other, and we'll see one of those are going to be monos, one's going to be epis. So let's do the source focus. So in the source focus, here's our F. We're focused on F. This is the thing we're looking at. And the source then of F is the domain of it is X. So the idea is, let's say you've got some other object with two morphisms from that object into X. So you get W, G, and H are coming into X. And the point is, let's say G and H are different maps. They're different arrows. When I say maps here, I mean morphisms or in whatever category. So the map is whatever is appropriate for that category. Well, if they're different, then there is some difference in how they relate to X, right? The way they push W into X, there's something different between them. If there wasn't anything different, then they'd be the same map. So they are the same, they are different maps, we're assuming. And so the point is, hey, if there's something different between G and H, well, F is going to be a mono precisely whenever these are different, F can detect the difference. So, F is a mono if it can always detect the difference. No matter, and this is no matter, so anytime you put any object in front with two different arrows that are in fact different, if F can detect them, then it's going to be a mono. So with that idea in mind, let's get to the actual definition. So then the actual definition, F is a mono or monomorphism in a category C, if and only if, so it's the definition. And then here, if for any, so for all, if you're not used to that, but if you've watched the video this far, you're probably used to for all G or H, where G and H have to be set up like this, where the actual definition makes sense, they're each coming from the same object into X. If for all G and H, if this diagram commutes, which means precisely that G followed by F is the same as H followed by F. So whenever those two are equal, that implies, in fact, that this diagram commutes, which is just a way of saying G is equal to H. I always like working in diagrams first. I think they're clearer and cleaner. But just to be clear, this is, or just to be comprehensive, here's what you usually see, which is just the equation form. So this is just translating the picture I just did. So in picture form, it says, G composed with F is, if G composed with F is equal to H composed with F, then that implies, in fact, that G is equal to H. So this is so-called left cancelability, because F here is on the left. And I'm just going to always harp on this. That's because we use the stupid conventional order in math. We don't use diagram order. These should be flipped. The diagram order would make much more sense, but I'm not going to fight that fight, even though I'll complain about it in all videos where I do this. So left cancelability, because we've chosen to follow the conventional order I've chosen to follow, at least in these videos. So then if we do the target focus on Y, well, everything's just going to dually flip around. So now we're same, some F. We have some arrow F, and now we're focusing on its target Y. And so now it's the same idea. Let's say you've got two different maps, G and H, where they each have the same codomain. They each start in Y. They each have the same codomain Z, say. Well, if they are different, F is going to be an epi precisely when, if these are different, pre-composing with F won't hide that difference. So on the other side with the monos, it basically said it was it had a distinguishability property where it was sensitive enough to always tell the difference, and it didn't hide it when it was post-composed. Now in the pre-composition, it basically says, hey, F is gonna map X sufficiently into Y in such a way that it sort of fills Y, and it's not going to hide whatever the difference is that are actually present in G and H. And so, do the definition similar, dually to what I just did. So F is an epi or an epimorphism in our category C, if and only if. And it's the same picture, just flipped. So if for all G and H, where this makes sense, if this diagram commutes, so F composed with G is equal to F composed with H, then in fact G and H are the same map. And so, in equation form, well, it's just flipped. So now it's, the F composed with G, F composed with H. If these are equal, then that implies actually that G and H are equal. So this is the so-called right cancelability. Again, the note that it's stupid conventional order. So in summary, a mono does not collapse distinctions coming from the source. So you had those two maps, and if they had a difference in them coming into if you have two maps and they have a difference coming into the source, if you then apply the mono, it's not going to hide the difference. It can detect it. So I'm saying it's got sufficient detection. And an epi does not leave room in the target for distinctions invisible from the source. So the point is now, for the epi, it maps an X into a Y, and it does it completely enough and coherently enough. I always got to be careful not to slip too much set theoretic language into it, that you still then see the difference when you post-compose with the two maps. And so I'm calling this sufficient coverage. Couple warnings. Monos actually are typically injective morphisms in categories where you have some sort of set with extra structure. So in things like group and ring, vec k, top, for all of those, well, actually injective is going to end up being the same as being a mono, in particular because morphisms already, like if you're in top, a morphism already has to be continuous. So then if you have a injective morphism, well, that means it's an injective continuous map, and that actually will be a mono. Should call it though, not all categories have set backbones. So a mono as injective can often be nonsense. So in particular, like here's an example: pre-orders. There's not a set underlying that. So in the same way, so it doesn't make sense to talk about the monos being injective. Epis are a little different. Epis do not always equal surjective, even in these set backed categories. And epi plus mono does not always imply iso. Often it does, and you want to know if it does. But as an example that is a counterexample to both of these, in the category ring, which is rings with units where homomorphisms preserve the units, you can look at the embedding of the integers into the rationals. That is an epi. It is clearly not surjective. It is also a mono, and because it's not actually surjective, it's also not an iso here. So there's the simple example of a counter there. But a lot of times, epi plus mono will imply iso, but it's not a universal. So you actually got to know if it's true. What's coming up next? I don't know exactly. I have some thoughts to start a series where I do the basic objects of algebra through categories. So things like defining groups as one object, categories where all morphisms are isomorphisms, defining rings as additive categories, defining R modules as additive functors. So at some point I'm going to make that series. We'll see how soon I start it. I still want to do tensors, exterior algebra, Clifford algebra sequence. There's a bunch more categorical fundamentals that I need to get to, so I'm not quite sure. I'm jumping about a little bit. This all does tie into that mathematical structures course that I want. I have a big old outline, and I think I'm just too impatient to start at the beginning and just work my way slowly through. So I'm sort of hopping through how I want all of that to go. If you check out that video, it talks about actually running through a bunch of these different things, and I'm more or less hopping around because this is my stress relief mechanism, and I'll make the videos that actually are interesting to me for the time being. But if you want something in particular, feel free to request it. No promises, I'll honor it. All right. Hope people are enjoying this. Until next time, be well.